Good morning, everyone. So today we are here to present Start Left with open source DevSecOps technologies. Myself Shruti, and I'm associated with Cyber PWN Technologies as Deputy Manager for Cloud Assurance Practice. I have 6+ years of experience in cybersecurity field, currently exploring DevSecOps and threat modeling. This is my first conference talk, so I would like to take a moment and thank Team c0c0n for providing us opportunity to speak at c0c0n 16 edition.
Hi everyone, a very good morning one and all. Myself Aswin Raj, I'm working as an associate manager for the cloud assurance practice with Cyber PWN Technologies. And I did my master's in cybersecurity, and it's been 3+ years into my journey with InfoSec domain, particularly into cloud security, DevSecOps, and application security. And yeah, this is my first time as a conference speaker, so if we get screwed, please forgive us. So I would like to take a moment to thank Team c0c0n for giving us this fantastic opportunity to share our research and thoughts with the global InfoSec crowd. So today what we will be talking about is a state of application security, DevSecOps beyond SaaS standards, a matured operational framework. Do we need to spend a lot to start? Threat modeling, starting left with open source tools, and a lab walkthrough of how we have done. And this talk is purely based on whatever we did for our customers. It can change based on the organization landscape and the compliance requirements and all. And we are not promoting any tools here. So before going into the talk, I would like to know who all are from a DevOps or DevSecOps background. Can you please raise your hands up if anybody is from that background? Yeah, I can see a few hands. So for you guys, some of these topics will be, repetitive. And for others, newbies, it would be an interesting topic, I hope so. So let's consider some of the, renowned statistics like Gartner, Forrester and all, the state of application security. So a Gartner report says that around 45% of the organizations will experience a supply chain attack by 2025. Similarly, the Forrester state of application security says that applications are the top cause of external breaches and supply chain contributes to the complexity. And similarly, one of the other report by Sonatype says that around there's a 742% increase in the supply chain attack growth rate from 2019 to 22. So the rate looked pretty alarming, right? The growth of supply chain attack and the global loss of supply chain attacks. So what can be the reason for a rise in supply chain attack over the years? And as attackers are not interested in carrying out the traditional web application attacks, definitely no. So what is your thought on that, Shruti?
Yeah, definitely, Aswin. Attackers are very much interested in carrying out the attacks using modern techniques. One example here I can give is chaining of the vulnerabilities. And if you closely look at the current application ecosystem, applications are not built in monolithic manner. They are built constantly and contain huge number of features, complex components, microservices, and APIs. Also, there is a heavy dependent on the third-party libraries which is incorporated during the development process. And as you all know, cloud has evolved the major component of the modern applications. The major attribute which contributes to current application ecosystem is releases. In earlier days, releases were less in number. Currently, it is happening frequently. And in some organization, we can say it occurs daily. So, Aswin, do you think the security can be in pace with the frequent releases?
So here comes the problem, because multiple stakeholders are involved in the software development lifecycle process, right? The development team, the operations team, the engineering team and all. So there is less collaboration between all the parties, and security is coming as a blocker for the release. Moreover, developers are not happy with the security team because they are blocking the release, right? So Shruti, based on your exposure to web application testing over the years, what would you see as some of the challenges faced by the clients to fix the vulnerabilities?
So when we talk about fixing the vulnerabilities, it is way much higher. The cost is way much higher in the production. And there is also an inefficient way of tracking the reported vulnerabilities, remediations, retest and rescan. And there are also so many, pending activities both from the development team and the security team. Now, Aswin, can you let us know what can be the solution for this?
So as we all know, only solution to this problem is adopting to a DevSecOps approach in the right way. So when we talk about the DevSecOps approach, when we talk to customers, many face a lot of challenges in adopting to a DevSecOps approach. And few of the challenges we have listed it down here. Few of the common challenges. So when we talk to customers, they may say that DevSecOps, yeah, just SAST and dust. I want to integrate it with my CI/CD pipeline, the job is done. But it is not just limited to SAST and dust. It is much more beyond that. Other thing is lack of security awareness. People may not be aware of the attack vectors that are possible or attack vectors that happened previously. So here, what the problem is, they should have an understanding of what all attack vectors will be possible in the near future as well. Also, as I've already mentioned, the collaboration between the different stakeholders will not be there. And the other thing is people who have evaluated application security testing products, you may know that the huge cost associated with the commercial solutions, right? And other thing is misfit in tech. Like we were having one of the customers who were using the legacy programming language Delphi. And the commercial solution that they were using Delphi was not supported, right? So what they need is they need a solution which support Delphi. So they have procured a tool which doesn't support Delphi. So these are some of the challenges we experience with the customers. Now, Shruti, how can we adopt a DevSecOps approach overcoming all these challenges?
Yeah. So there is a fundamental change which is required. That is, a fundamental change is required in the mindset of the people and the organization. So let's take an example of COVID, where people were hesitant to get vaccinated because of the various information received that it might cause some after effects. Gradually, the people got vaccinated and issue was solved, right? So similar is the case with DevSecOps. The mindset of the people should be changed. And now when we say it should be changed, now we'll be asking, where should we start? And answer to that is start left approach. Again, you all might be confusing like what is start left, shift left, because you have heard many times, right? So let me tell you, shift left is something you're considering security at early stages of your development, which is SAST and DAST. Again, we have already said that it is not enough. It is not just limited to that. You have to go one step, like extreme left or one step behind to consider or even your application is born. And that is what we call as start left approach. And the major challenge here and that we have to overcome is the communication. As you all know, in any organization, communication plays a very important role. So similar is the case with DevSecOps. There should be a good collaboration between stakeholders, development team, security team, operations team, and the infra team. And one major principle which I would like to highlight here is it should be more of a risk-based approach rather than a compliance. Because we all know the compliance is just like we say check, KPIs, reporting, etc. That should not be the case, right? So Aswin, can you show us how the framework will look like?
Yeah. A mature DevSecOps operational framework, based on our experience, we have designed a framework, and this would consist of different factors, as you can see from here. So here you can see the different stakeholders who are involved in the process, the business owners, the end customers, the CXOs, the development team, the operations team and all, and some of the key drivers that is driving the adoption, the regulatory requirements, the compliance requirements and all, and basically your CI/CD pipeline, your SDLC workflow, starting from the planning stage till the monitoring stage, on which we are applying the DevSecOps technologies, SCA, SaaS, container scanning, threat modeling, and the list goes on, right? And some of the other things is the culture and governance. If we have adopted to a DevSecOps approach and if people are not using it, what's the point of adopting to that? So everything should be clearly defined. People should have effective communication, roles and responsibilities should be clearly defined so that you will get the best outcome. And what would be the best outcome? You can see a security by default design, early detection of vulnerabilities, and the cost reduction, and the list goes on. Now, you may think that if you need to adopt to a DevSecOps culture or if you want to experience a DevSecOps culture initially, you want to adopt or you want to spend too much on adopting or purchasing commercial solutions. But Shruti, do you think that we need to spend too much on purchasing commercial solutions to approach a DevSecOps approach?
Definitely no, Ashwin. It is not required to spend too much if you want to start DevSecOps approach. So let's take an example of the real-time scenario in what happens in organization, be it any organization. They will evaluate any tool for 1 or 2 weeks. And do you think this is enough? The answer is no. Because within span of 1 to 2 weeks, you'll not be evaluate the correct set of tools or that will meet your business requirements. So what we suggest here is, once you're at the maturity level where some business use cases cannot be met by the open source solutions, you have to opt for commercial solutions. So now you can see here that we have implemented a great set of tools from planning to design, from plan and design to operate and monitor. We have implemented all the open source tools here, which will be acting as an initial enabler for your DevSecOps. It's a good way to get started. But Ashwin, do you think this is enough?
So people who are into, I think I can see some of the DevSecOps support, you can, you may feel like this is an immature model, right? Because it is just having the basic components. But the thing you should consider here is, it is having around 30 or 40 set of tools, and to adopt to the 30 or 40 set of tools initially, it would have adverse impact on your SDLC. Your releases will get blocked and it will have a lot of issues, right?
Yeah. So we have not included many use cases such as, privileged identity management, CSCD poisoning, code signing, secret management, etc. Because that would take 2 to 3 hours to present here. And we had to request Team Cocoon, which is not possible.
Yeah, and the entire conference days wouldn't be enough to complete that, right? So Shruti, how can we start with, your start left security approach now?
Yeah, so we have spoken the start left approach, and now we'll see how we are implementing it. So here we are using ThreatDragon, which is again an open source tool developed by the OWASP community. So what is threat modeling? To simply put, it is a systematic way of deriving potential threats and vulnerabilities at an early stage. That is, even your application is born, right? So some objectives to consider when you start performing threat modelings are, so let me give an example again here. So assume that you have created or you have developed an application, and now you want to implement SSO functionality for that. What happens is, again, you have to come back to the process, implement, design it, implement it, and write few set of lines, or maybe some technology landscape is also required, like where you have to add some programming languages or frameworks. So now you consider or you imagine the time, effort, and the budget wasted here. You have to roll back, right? So your approach should be to the risk-based, not just do perform or just start doing the SAST and DAST. And this, when you implement or when you start doing a risk-based approach, that will lead you to deliver a better product also with a predictable schedule time. Why? Because the redesigning and refactoring of your design issues will not come at a later stage. So we have mentioned here some misconceptions when we have a customer interactions, right? They say, okay, planning, this pen testing, code review is enough to be secure. True, that all fixes, your issues will be fixed at the code level. But what about the design issues? So threat modeling will let you solve issues at the design level. So other few common things are like it cannot be done after the deployment, and it is complicated. Yes, it's complicated, we agree, but at a glance. What if you start adopting it for a simple web applications or a complex web architecture? You can start doing it by breaking down or decomposing your application, and that's the best way to get started. And there are many frameworks available in the market where you can get started. And one of the most famous is the Stride framework, which is good enough to start. There are others as well, like Pasta, Attack Tree, Mitar Attack Tree, and so many, right? VAST is also one of the good framework which is upcoming in the market. So, yeah. So here you can see a screenshot of the ThreatDragon tool, which is generated. And more about it, I'll showcase it in the lab walkthrough. And you also get a PDF report generated by the ThreatDragon, which comes with all the issues, description, remediation, and a sample screenshot and risk associated with it. So this will help for you and the development team, right? So before we proceed ahead with the second phase of the DevSecOps process, so I just want to give away a few tips or just like thumb rules, like how you can get started easily. First is understand your requirements when you're building any application or a product. Understand your requirements and decompose those. So decompose is basically put into smaller components. And then define your trust boundaries and the data flow which is happening between the components. Now sit down and identify all the possible attack vectors, potential threats, risk associated with it. The last thing is like you have to sit down with the teams, the multiple teams, the architect team, development team, and the security team as well, where you can identify the missing vulnerabilities or the threats associated with it, and educate the people, because it is very important, like how impactful or how great impact it has when you start doing early. So now we are done with start left. Aswin, can you tell us what are the next steps?
So we have seen how to start left, exactly. So here, this is done at a stage even before your application is born. No developer has started writing the code, right? So based on the feedback received from the threat modeling team or the security architect, the developer starts writing the code, what are use cases, business functionalities they need to include. So the first thing when it comes to our mind, when it comes to code security is, open source dependencies, your native source code and all. So we should start with SE and SAST. So before getting into SE and SAST, let's talk about software supply chain security, software supply chain, the terms we are hearing for a while now. Okay, so let's consider the manufacture of a car where we can correlate it to the source code, the native development of an application. So in most cases, the car engine would be developed in-house, right? That we can correlate to the native source code of the application. Other thing is some components like your headlights, infotainment system or wipers, they will be outsourced. We can correlate it to the open source components which are used in the code. Other thing is the warehouses or factories where the car is manufactured. That is basically your DevOps or CI/CD processes. Other thing is the manufacturers of the car or the laborers of the car. We can correlate it to the software developers, the testers, the security architects and all. Now, software supply chain contributes to all these components. Whatever open source components are included in your code, your native source code, the people process everything that is included in this. And software supply chain security contributes to securing all these components, right? Now, when we talk about software supply chain security, we should consider two things. One is securing the code itself and securing the pipeline itself. So when we talk about securing the code, we should secure the native code that the developer is writing. And other thing is the open source libraries that they may pull out from some other, some other sources, right? Now, securing the pipeline. Let's consider a water flowing through a pipe, a simple example. And within that, what we need is we should secure, the water shouldn't get polluted and the pipe shouldn't break. Similar is the case with the source code flowing through a CI/CD pipeline. The code shouldn't get malicious and the pipe shouldn't break so that the code may get leaked to the attacker and it can cause a lot of problems, right? So we need to secure the pipeline itself and secure the code itself. Both are important, right? Now you can see some of the recent supply chain breaches. You might be aware of this, the Progress Move It breach, the SolarWinds, the Log4j, which created a big havoc in the InfoSec industry, right? So we have seen what is the software supply chain and software supply chain security. Now let's understand what is SCA or software composition analysis, what exactly it is doing. Okay, so the developer starts writing the code and they won't be building the code from scratch. Like if they need to make an SSL connection, they will use OpenSSL. If they need to do logging, they may use Log4j. And they may or may not think whether if that particular open source components they are using is having some security issues. Some may think, some may not care. And we need to understand whether that open source components are introducing some issues. So for that, we are adopting a technology called a software composition analysis, SCA, which can detect the security issues associated with your open source components. Moreover, you might have heard of the term SBOM, the software bill of materials. So that is basically a list of all the open source dependencies which are used in your code, okay? So how come it is important? Because say for example, an application was developed 10 years back and after 10 years, your Log4j was reported. We need to understand whether in that application, if we are using that Log4j, that particular version which was having the RC vulnerability. So that what we can do is if you're having an SBOM, it would be easy, right? And another thing is the US department or the US government has released an executive order saying that SBOM should be made mandatory for all organizations linked to the government. So there comes the importance of an SBOM, right? So for our research, what we are doing is the OWASP dependency check, the famous tool which can handle the software composition analysis and give you a better results. And you can see some of the sample screenshot from OWASP dependency check. Yeah, and this is a report of OWASP dependency check, which is basically comparing with the NVD database and identifies the CVs and all. So we have seen how to start addressing the open source library issues. Next thing is we need to start securing the code. The developer may write the code. They may or may not care about, if some proper input validation has been embedded in the code, or else if some secrets are embedded into the code. So that needs to be scanned, right? Because that are very much important. So for that, we are adopting the technology SAST, Static Application Security Testing, which is basically scanning each line of code and giving you the security issues. Now, what happens is, if you scan with a SAS tool, it may give out a lot of false positives or it may give out a lot of results. The thing is, you need to head back to the developer to get it fixed, right? Now, the developer may say, how come my code is bad? I'm a good programmer. Your tool is saying that my code is bad. How can it be? So we need a solution which give results. I am not telling that every SAS tool will give better results. But based on our research, what we have found is SemGrub as an amazing open source solution which you can adopt initially, which can give you amazing results to scan your application source code for vulnerabilities, right? And you can see some of the sample screenshots generated by the SEMGRUB tool, which we can cover in the lab walkthrough, which we are doing at the end. Yeah, we have addressed all the, code security issues. Are we ready to deploy the application to production? Now, here we should ask the question, right? If we consider modern applications, it will have a lot of microservices, complex components, APIs and all. As such, they will be secure. But when they are working together, will they be secure? What's your thought on that, Shruti?
Yeah, definitely. So let's have a look at the DAST, which can be done using the DAST. As you all know, and we have mentioned showing the Gartner survey, that applications are the #1 reason for the security breaches. So how do we perform the DAST? So a DAST is something where you can simulate what an attacker does to compromise the application, right? So it comes in many variants to cover the application testing or use cases, right? So it can be API, mobile, the client, and the black box and the gray box as well. So we have used OWASP ZAP again, which is developed by the OWASP community. Now you have a question like, what does it do? Okay. So ZAP tool is something which crawls all your endpoints, URLs, APIs, and it sits between the client and the server so that it can manipulate or tamper data and send it to the server. If it is successful, then the reports, it will be reporting a vulnerability. And you can see here in the screenshot that how the vulnerabilities are being generated. Next. So here are the list of crawled URLs. You'll be getting it on the left menu or the left pane. And here is what I said of manipulating your request header and the body. And vulnerabilities will be generated. So about removing the false positive and true positive, that will see it again in the lab walkthrough. So now we are done with DAST. So do you think the application is ready to be deployed in the cloud? Aswin.
So here what we need to understand is when we talk about modern applications, okay, they are containerized. So how come the containerization technology helps us? So earlier there was a problem, with the development team and the operations team. The code is working on your machine, but when it goes to the server, it's not working. So there comes the introduction of containers. What basically it is doing is, it is packaging all your application dependencies, libraries as a container, which you can deploy it on top of a Kubernetes cluster or whatever deployment model you are having. Now, we need to understand what is container security, because before the container image gets stored in that particular container registry, we should ensure that it is secure from vulnerabilities. So what we can do is, we can use a container scanning tool for that. And let's understand how a container can introduce vulnerabilities. Let's say, for example, if you are building up a container, the first thing that the developer or the DevOps team will be doing is a Docker file, which is the where we are mentioning all the commands required to build the container. They'll be using a from statement there, from where they are pulling out all the base image required to build the particular container. Base image is particularly the foundation of the container. So that base image itself can introduce a lot of security issues if they are pulling out that particular base image from not from a trusted source. So we are using a scanner called as Trivi. It's an amazing container image scanner, which can give you the results for scanning your container images and gives you the results. And this is some of the sample screenshot that Trivi provides. Okay, so here it is saying that a particular dependency and which is having 1.3.2 version, we should upgrade it to the next version because it is having a remote code execution vulnerability. So this comes, how we can secure our containers. Now, next thing is, container is ready. We need to deploy the application somewhere, right? To deploy the application, what we need? We need an infrastructure. So when we talk about, earlier the applications were developed on, deployed on some bare metal servers or, your on-prem servers, right? But gone are the days, we are deploying the applications on the cloud, AWS, Azure, GCP, whatever your technology landscape is. So we need a solution to scan your infrastructure. So before your infrastructure gets deployed, we are scanning your infrastructure as a code file. So you might be aware of what is an infrastructure as a code file is basically doing. Because if we need to create an EC2 instance in AWS, what we all do is go to aws.amazon.com, create an EC2 instance, next, create security group, next. That's a time-consuming process. If you want to create around 150 or 200 such servers, it is a time-consuming process, and if it is not proper, configured properly, it can introduce a lot of issues, right? Because we all know that the #1 cloud security issue is cloud misconfiguration. So before that, we are taking a start-left approach by scanning your infrastructure as a code files. So this infrastructure as a code files, we are mentioning what all commands are used to build that particular infrastructure. Like if you want to create an EC2 instance, we will be writing that script for that. So we are scanning that particular IAC script if it is introducing some issues, so that before it gets deployed onto that cloud environment, we are scanning it, taking a start-left approach. Because you know that when it is deployed in the cloud, it is in the production and it can introduce a lot of issues, right? So we are using the same container image scanning tool we employed, the Trivi, which is having an additional capability of scanning for your, IAC scripts, your Terraform scripts, which can scan, give you issues like if some open ports are there, or if some S3 buckets are publicly exposed, all that details you can get from that. And this is some of the sample screenshot that the tool provides. And here you can see that the main.tf file, which is basically your Terraform file, okay? So it is giving that S3 buckets are not encrypted. What you need to do is just encrypt your S3 bucket, then that particular issue is gone, right? So after this IAC scanning is done, what we do is we will deploy that particular infrastructure. No, still are we secure? But we should consider one thing. Say for example, we have deployed the infrastructure with IAC. The cloud administrator is going to that aws.amazon.com and manually making some changes. Like he may feel like I need to open one port or to the internet. So he may go there and manually open that port, right? So we need to scan that as well, right? I mean, the runtime related vulnerabilities in the cloud. So for that, what we can do, Shruti?
Yeah, so all we need is a quick solution that will identify all your misconfigurations in the cloud environment because it's already in the production now, right? So what actually a CSPM solution does, it leverages your API so that it can identify the misconfigurations that are available in the cloud. And again, this should meet the industry best practices and the security standards as well. So let's take an example of AWS where S3 buckets are misconfigured, and in Azure you can take an example of NSG fire rules where it is publicly exposed, and App Engine firewall as well, rules which are again rules are misconfigured. So all in this all cases, what is being done is you need an automated solution that is being done by the CSPM solutions. Here we have used Scout Suite, which is again an open source tool, which will help you identify all the misconfigurations in the cloud environment. Here you can see a sample screenshot of that, where EBS volume is not encrypted, which should be encrypted to secure your data. So now you can imagine the list of vulnerabilities because you know we have came from like the start left, from the threat modeling till cloud. Imagine the list of vulnerabilities both the development team and the security team has. It's a big nightmare to both the team. So now what we need now, we need an application security posture management, right? So Aswin, can you show us some insights about that?
So we started with threat modeling. We did SES, as container scanning, IAC and all. A huge list of vulnerabilities, right? Who knows that what is fixed, what is pending in the backlog, and what is false positive, and what are the out of scope things? Who knows that? I don't know. Nobody knows that. So we need a solution which can give you, the track of the vulnerabilities which has been fixed and which are pending in the backlog and all. So here we are using a tool called as Defect Dojo, okay? So which is basically used to track the vulnerabilities and get an understanding of where your application security current posture is, right? So it can give you the details of what are false positive which are marked and what are the new issues which are introduced and what are pending in the backlog. All such details can be get from the Defect Dojo dashboard. Moreover, it can give you the details of, if the organization top level executives, they need to understand whether that particular solution, if they need to understand the application security posture, if they are all good to release into the production. So they can use this particular solution there, right? Okay, so this is some of the sample screenshot from Defect Dojo which we can show in the lab walkthrough. And other thing is, we need to get a track of all the, that particular CI/CD servers which we have employed, or the applications which is deployed, or if we are deployed any tools for scanning your application source code. So we need to get a track whether it is working properly, if the network traffic is good. So all such details can be integrated with the ELK stack. Everybody's favorite, logging and monitoring tool, the favorite open source tool, which we can use to track the issues, if the network traffic is good or bad, and if some DDoS attacks are there. So all these things can be from the ELK dashboard, right? So this is one of the sample screenshot from ELK dashboard. Hope you are aware of this. Nothing to explain more here, right? So putting it together on our lab, how we have transformed this SDLC to a secure SDLC. You can see that how basically a DevOps pipeline look like, starting from the Git checkout till the deployment. And where we have integrated the security, you can see from the orange color, right? See, okay. Now, yeah. So this is basically how we have implemented StartLab with open source DevSecOps technologies, right? So we have started with the threat modeling. The product architects have started doing threat modeling, and then we are fetching the code from GitHub, and all your SES dashed, all things are done. And post that, whatever ELK stack, defect dojo, everything, you can see it from here, right? So we have seen a huge list of things, a huge list of tools, but you will be very much interested to see how it actually works, right? So Shruti, can you show how it actually works by your start left approach?
Yeah. So as we said that we'll be starting it from the let using the ThreadDragon tool. So this is how your main page of ThreadDragon would look like. And it is very simple process. All you have to do is go to any browser, just search for it, and you can easily download, right? And it is very quick. Once you are installed, just click, and everything is ready to get started. So here there are three options. One is for the existing files. If you have already built, you can open it from the first option. And the third one, the last one, which you are new and if you want to explore, which is again given by the ThreadDragon itself, you can explore more on that. The plus symbol, which is used to create completely new threat model right from the scratch. So let's have a look at it. So once you click on this, this is the set of things which you need to fill in. Whatever is required, just fill out. And here, to keep track of your the model name, just be sure to give the diagrams and the high-level description of what you're developing. So for example, an application can be a banking or a fintech or a retail application, right? So then just click on Save. So this is the page which looks like when you want to get started, and I just want to simplify it. So the three parts, the middle part is the main part, and that's a white canvas sheet wherein you'll be using all these components to build a threat modeling. And you can see here at the end, the manage threats, which is used to identify all the potential threats and vulnerabilities. So about the third part, the properties, we'll see it in few seconds. And you can see in the upper right corner, there are frameworks available. Again, this is again given by the tool itself, Stride, CIA, and Linden. So Stride is one thing common, and I have used the Stride framework only to develop here. And there are options to save and delete, which is very easy to get. I mean, you can know that. So if you want to have a version, which version it is, currently I'm using 1.6.1 version. And the latest version is 2.07. Okay. So now what you have to do is you have to select all these components. Now the first thing is you have to take an actor. Actor is basically you can define your user roles, right? It can be a user or admin user role. You just have to drag, simply click on it, and it will be available on your canvas sheet. And the process is something where your data is being stored. Example I can give you is the web server, which is used to store the data. And storage is something, it can be your configuration files or let's say the database. That is where these three components play into picture. And I have said or talked about the trust boundaries. So once you have identified all these components which are required for the web application, so here it's a very simple web application. I've taken only the normal user and the admin. So when you're developing for a real time, the components will be many. So this is what you have to first identify, and then use your trust boundary and the data flow which is exposed. So when we say trust boundary, one example which can be easily correlated is whether it is facing to internal or external, and you can also so like your load balancers, WAF, how they are placed, where they are placed. So it should have some boundaries, right, which are facing to internal or external, right? So that is where the trust boundary comes into picture. And data flow is something all know how your request is being sent or received. That is basically, it can be a unidirectional, bidirectional, or multidirectional. So that is what you have to decide here at the second phase. So about filling all these details, you have to just click on the component. For example, for here, user, just a normal user, and if you want, you can provide the description. And there are other options if it is providing like authentication or not. So if it is yes, then you have to click the checkbox. Similar is for all the components. So in a similar way, you have to start developing it. So let me show you once it is completed. So this is how it looks like when you have identified everything, the flow and all. So I said the properties we can speak about in a few seconds. So when you want to define the flow, you can just click on that line, flow 9, and settings, then you can fill out the data. It can be the HTTP or HTTPS or the request being sent. That is where the properties comes into picture, and you can ensure whether it's encrypted or not, which should be taken care, right? So just give me a minute. So now we are coming to the managed threads, which is the most important part. So whenever you want to add a new thread, right, you have to just click on the component which you want to define it for. You can do it per component. So when you want to do it for the user, just go there, click on add new thread, and the vulnerabilities related, like potential threats or vulnerabilities we can identify, you can just put it there, right? So yeah, you can give a title and the stride thread type. Okay, so now your question is like, what is stride, right? So how it is being defined is based on the 6 parameters or attributes, we can say. The spoofing, tampering, repudiation, information disclosure, denial of service, and privilege escalation is what it is being derived from, and that's why we are using. So if you want to classify any of the associated risk or threats or vulnerabilities, you can say, you can just classify one of the 6 categories. So here I've just taken an example of tampering, and you can define your own threat status. So it's new and it should be in the open state. So the priority also can be defined by yourself based on your environment and the requirements. So I have just given it as high. And provide a simple description and mitigations, because again, this will be, the document or the data will be sent to the developers, which even they should be understanding it. So good references and simple terms will be really helpful here. So similarly, you have to perform or add components and threats. To each component, you have to add threats. This is how you can build a threat model. And there are other options, which you can see here, stride per element. So this is what the threat dragon tool does is, it automatically suggests you a few of the threats when you have developed. So if you think that is acceptable, I mean, if it's required for your application, just simply have to accept it. Otherwise, you can ignore it. So this is how it looked like when you want to use a stride per element. So this is the one generic tampering thread given by threat modeling. If you think it is fit to accept, then you can just simply say accept and then otherwise ignore. So this is how you do a threat modeling for a simple web application. So we are done here. So Aswin, can you show for the rest of the process?
Yeah, thanks, Shruti. So we have seen how to start life with threat modeling. So the next thing is the developers started writing the code, and we need to understand how the things are working now, right? So the first thing is, whoever is writing the code, you will be having managing your code in your particular GitHub, GitLab, Bitbucket repository. And after that, yeah, I'm just heading over to my Jenkins platform, and here you can see some of the basic pipelines which I have created. Okay, so this is my CI/CD pipeline, how it looks like. So let's see how the process works here. So first I'm fetching the code from GitHub, building code, doing software composition analysis, testing, SAST, DAST, all the things I'm performing from here. Now let's see how the results look like from here. So here you can see how the pipeline is getting executed. Okay. So the first thing is we are fetching the code from the GitHub repository in this case, and we are building the code. Next thing is we are doing a software composition analysis with the OWASP dependency check tool that we have discussed now. And you can see that the process has failed here, because the thing is here, if you just go to the results, you can see that it has analyzed for the open source dependencies and generated a report in XML format. Okay. And the next thing is, you can see here, the findings exceeded configured thresholds. From here, you can see it. Okay. So the thing is, I have written a policy like if there are more than 2 high severity vulnerability, I mean 2 open source packages, I mean if open source packages are having any high severity vulnerability for more than 2, it should fail the process so that it shouldn't go to the deployment stage. So it has detected 2 high severity issues, and next thing what I need to do is I need to again tell my developer to fix that issue. He will go to that particular pom.xml file and change that particular open source dependency. Then what happens is the commit will be made and the process starts again, and then the next iteration you can see that the SCA has been success, and after the testing is done, then the static application security testing with semgrub is done. Here you can see that it has also failed. Why? Because I have written like if there is a SQL injection vulnerability in the code, it should fail the pipeline. Okay. So it has detected some of the SQL injection vulnerabilities in the code. Okay. So here you can see the SQL injection vulnerabilities. It has detected in the code the particular line number in which the issue exists. So it needs to be fixed, right? Before it gets deployed in the production environment. So in the next iteration, what happened is the developer has fixed that particular issue, the pipeline is successful, then the dynamic assessment is done. Here also some issues are reported, and you can see that I'm scanning this particular URL, okay? So after that, it has also failed the pipeline, and it is fixed in the next iteration. Next comes our containerization, okay? So containerization is to containerize your application, libraries and all. So the containerization of the application is done. Post that, we are scanning the container image with the Trivi open source scanner. And here you can see that it has failed the process, because here I have shown that if there are high severity issues in my code, it should fail the pipeline. And it has detected some of the high severity issues in the code, okay? And it has failed the pipeline. So the next thing is there should be some changes should be made in the Docker file. So again, the developer needs to fix that, and the pipeline starts running. So in the next iteration, the Docker file will be written, and a new container image will be built, and the application scanning will be done. Okay. Next, our infrastructure scanning with the Terraform script which we are using. So here also we are using the same Trivi scanner, and here you can see that if there is a critical severity issue in the code, it should fail the pipeline. It has detected some of the critical severity issue. You can see that the security group is exposing some ports to the internet, which is a critical severity issue, and that should be fixed, right? So in the next stage, this is fixed, and we are getting a clear pipeline without any issues. Next thing is we are uploading all the results to Defect Dojo dashboard. Here you can see all the SCA, SAST, IAC, container scan results. Okay. So if we need to get what are the risks accepted based on your use cases, it is visible from here. What are the total findings, active findings, mitigated, all such details would be available here. Now here you can also see some of the metrics. What are the open findings? What are the risk accepted findings? A graphical format, it would be visible from here. Okay. Now the next thing is, if you want to get some individual result, you can just go to the individual result and see the description and mitigation of that particular issue. Okay. And say for example, if you need to assign that particular issue to your developer, what you can do is you can just go to that options and just request a peer review. Okay. After that, it would be assigned to that particular user, and that would be your developer, and the developer needs to fix that issue and mark in Defect Dojo that it has been fixed. So this is similar as a case with your DAST and ISC scanning, right? And here one more thing I would like to show is we can also get a list of all the open source dependencies which are used in the code. You can export it to the Excel format, CSV format for your reference as well. Now at the end, we are using the ELK stack for monitoring all the logs. Okay. So here you have seen how we have implemented the code security. Now you may think that CSPM is not included here. Why? Because cloud security scanning is done, once the cloud environment is deployed, it has nothing to do with your code changes, right? So because if there is code change, only the pipeline will get executed. So we have done the Scout Suite open source tool as a separate thing. So here, if I just open this, so these are basically the commands used to install the Scout Suite tool in your machine. Okay, it is very easy process. Just run a couple of commands in your Ubuntu instance. Okay, and next thing what you would need to do is, if you need to scan for your AWS infrastructure, you need to give AWS configure command, okay, to configure your auth token and all, the region and all. Post that, we can run a command python scout.py AWS, which is basically launching a scan on your AWS environment and giving you the issues. And this is going to take a while, and at the end, we are getting an HTML report and a JSON report as well. The JSON report we have uploaded to the same Defect Dojo dashboard, our centralized tracker. And here you can see each and every individual issues we are tracked, and it can be assigned to that particular cloud administrator, and they can fix that. But the better way to fix is fix from the IAC level itself, because there will be some changes with the IAC script and the cloud environment. So better way is to fix from the IAC than deploy the infrastructure. So this is all how we have implemented the start left SDLC security, starting from the threat modeling till the CSPM. And I hope this was a good talk. Thank you for your patience listening to us. And we need to get feedbacks and improvements from us. And this is based on our research and based on our interaction with the customers. And if we have done something wrong here, because this was our first conference talk, please forgive us. Thank you all.